Hi, I'm Devin Srivastava, and I'll be presenting Experiment 2, the magnetic field of a bar magnet. To get an understanding of the lab, it is important to get an understanding of the formulas which can help calculate the magnitude of the magnetic field. The first expression calculates the magnetic field given a constant and the distance from the source. The second formula finds a magnetic field upon a certain axis in which the magnetic moment is used. The third formula linearizes the first formula using the natural log function, and the fourth formula gives the off-axis magnetic field, and in this lab is used to calculate the magnetic field of the bar magnet with respect to planet Earth's magnetic field. The purpose of this lab is to calculate the magnetic field of a bar magnet and visualizing the results through graphing and coding. To set up this lab, you have a bar magnet at one end of a tape measure, and you keep a magnetometer, in which this case is the phone, to somewhere along the magnet, in which we'll measure four distances. One of which is where you calculate where it's 20, where you measure 20 microteslas, one at 70 microteslas, one at 120 microteslas, 170 microteslas, and 220 microteslas. Once you calculate all those distances, we use a common value dperp, and we use one of the measurements, and then also calculate what happens if we measure at a 45-degree angle. So now we have it upon the x and y axis as seen below. And then we use the same distance along the x and y axis, and then calculate that value d. And on top of that, we try to calculate the results of the magnetometer. These are the results of my calculations. You could see on the left side is part one, in which we calculate the distances. Then I took a certain distance, 0.2 meters dperp, and then measured exactly how along that same point. The results are seen in the graph, in which we get a y equals mx plus b expression, which is the same as formula 3, which was the natural log function, which we'll discuss on the next slide furthermore. The calculations seen on the left take into account the first two expressions, and then you utilize that in the third expression. You can see that we use that to calculate the magnetic moment as 27.3 Newton per Teslas. In the lab, there was also an experiment-based question in which we were asked, which of the statements describe what you observed? And in the lab, we find expression 1 and 4 to be the ones that I observed in the lab. This one, pretty much, if you take a magnet and move it closer to the magnetometer, you'll notice a greater magnetic effect of the magnetic field. While you move it further away, it'll decrease. This is the coding function I created to calculate the magnetic field, which is pretty much the replication of Formula 2, which I discussed earlier. You calculate the R magnitude and the R hat value, and then use those two values to calculate the magnetic field B. This is the result of my code snippet. You could see the D was just 0.32, and the B at 40, magnetic field at 45 degrees, that certain distance is given in the X and Y component. Some possible errors that could possibly happen while performing this lab is that the results are very reliant on the surroundings. For instance, if you were, let's say, to perform the experiment near a lot of electrical or magnetic devices, then the results can be skewed. And to give an example, let's say you were working near a bunch of laptops. Laptops use metal, which does get attracted to magnets. One issue which I encountered in my lab earlier on is that I was getting some weird results because of this. On top of that, a mobile phone is not the most reliable tool to utilize as a magnetometer. Obviously, you would want an actual magnetometer, as it is easier to tell where from the device the magnetic field is being calculated. If we were to perform the experiment not taking with respect magnetic north, then the results could be skewed, as there would be a differing magnetic field moment in all three directions, causing calculations to be off. If we use two identical magnets stuck end to end, then the magnetic pole would also be greater, so the magnetic field calculation would be greater. Thank you so much.